The discipline of statistics involves collecting and summarising data. The facts or pieces of information we collect are called data. When working with statistics, it's important to be able to recognise the different types of data in order to appropriately analyse, interpret and present them. In this video, we'll be looking at the relationship between statistics and data, why data is important, categorical variables and data, including nominal and ordinal data, numerical variables and data, including discrete and continuous data. Statistics comprise the collection, analysis, interpretation, and presentation of data. One piece of information is known as datum, where lots of pieces of information is known as datum. A list of information is called a dataset. If it isn't organised, it's called raw data. There are two broad types of data we're going to look at, which is called categorical and numerical. First, let's look at why data is important. The ability to analyse and act on data is increasingly important to businesses. The speed that things are changing requires businesses to be able to react quickly to shifting demands from customers and changing environments and conditions. Business decisions are becoming more complex, and businesses now compete in a global marketplace. For example, a small family-owned business now competes with a large multinational company like eBay that have access to huge amounts of data. Business owners and operators need to analyse and understand high volumes of data before they can make decisions. In my statistics introduction, I showed a couple of slides taken from Google Trends, where I was comparing the search terms Toyota and Ford over a period of time. This is analysed data to be very information to businesses who might be running a motor vehicle sales business. This is displayed on a map or geographically. The motor vehicle sales business might be very interested to know whether people in their country are searching for Toyota or Ford. This is data that would be very handy for them to whether they were making decisions whether to import Toyotas or Fords into the country. Categorical data represents characteristics such as the person's gender, marital status, hometown, or the type of movies they like. It also might mean race, sex, age group, or education level. Categorical data can be either nominal or ordinal. Nominal data is categorical data without any particular order. Nominal data can take on numerical values such as 1 indicating male or 2 indicating female, but these don't have any mathematical meaning. You couldn't or wouldn't add them together. Other examples of nominal categorical variables or data include country of birth. You might have United States, Japan, New Zealand, Australia, or eye colour, green, brown, blue, or hazel. Ordinal data mixes numerical data and categorical data. The data falls into categories, but the numbers placed on those categories have meaning. For example, rating a restaurant on a scale from 0 to 5 stars gives ordinal data. Ordinal data are often treated as categorical, where the groups are ordered when graphs and charts are made. Examples of ordinal categorical variables include agreement, so you might agree, neither disagree or disagree. You're generally going to have them in that order or flipped around to disagree, neither agree or disagree, or agree. You wouldn't have agree and then disagree and then neither disagree or agree. Another one you might find is risk rating. When you're looking at low, medium, and high, you don't write low, high, medium. It just doesn't make sense. Numerical data has meaning as it is a measurement, such as a person's height, weight, IQ, or blood pressure, or their account, such as the number of stocks a shared person owns, how many teeth a dog has, or how many pages you can read in a book before you fall asleep. Categories can be either discrete or continuous. Discrete numerical data represents items that can be counted. They take on possible values that can be listed out. The list of possible values may be fixed or it may be infinite. So it may go from 1 to 100 or it may go from 1 to infinity. For example, the number of heads in 100 coin flips takes on values from 0 through to 100. but the number of flips needed to get 100 heads takes on the values from 100, the fastest scenario to get 100 heads, which is pretty unlikely, up to infinity, because you may never get 100 heads. You may get infinity tails, but we know the probability isn't likely. Examples of discrete numerical variables include cars in a car park. Could you take any of the values 0, 1, 2, 3 up to any number depending on the size of the car park? You could also go students in a classroom, generally values up to 30, but it could also take on any value depending on the context. You might be a classroom in a university where it could be up to hundreds of people. Continuous numerical data represents measurements. They can't be counted, can only be described using intervals on the real number line. For example, the lifetime of a car battery can be anywhere from 0 hours to infinite number of hours if it lasts forever. Technically, with all possible values in between. Granted, you don't have a battery that lasts more than a few hundred hours, but no one can put a cap on how many hours it's going to last for. Examples of continuous numerical variables include the amount of fuel purchase, starts at 0, and continues up to the size of the tank. The time to run a 100-meter race, likely between 9 and 25 seconds, depending on the runner. Likewise, you might measure someone's height or measure the weight of something. These are all continuous numerical variables. A good way to visualize the data types is in a tree diagram. You have the data that branches into numerical and categorical, and then branches into continuous, discrete, ordinal, and nominal. In this video, we looked at statistics and data, why data is important, and the categorical types of data, and the numerical types of data. Thank you.